Welcome to my YouTube channel. Now I'm going to start the new topic, that is pericyclic reactions. This chapters in CSR net and gates for CSR net, CSIR net and gate. The questions are frequently asked from this chapters, that is pericyclic reactions. It means that we will not get that individual questions that we can get, but very less. But the questions from pericyclic reactions that will added in between the questions, like give the lot of reagents for a single questions, and in between that they will add the questions from pericyclic reactions. It means that if we don't have the knowledge or concept of pericyclic reactions, then we can't solve that the whole questions. Means we will stop in between the questions. So knowing the chapters of pericyclic reactions is very important to score good marks in CSR net and GET. And this pericyclic reactions, this is just it has to understand the concept, and some tricks are there that I will discuss clearly in these chapters. So if you just listen to it, then we can understand that, and very less concepts are there. And if you understand that, you just use the tricks, then we can easily solve the questions from pericyclic reactions. So let's start the chapters pericyclic reactions. So this pericyclic reactions, from chapter itself we understand that this peri means, peri represents that around, okay, and this cyclic represents that cycle or link. It means that from these chapters we understand that that in organic reactions the main thing is that the movement of electrons. Organic reactions means that we should understand the movement of electrons. That is actually the basic things about an organic reaction. So in these pericyclic reactions, what we see that the movement of electrons we will see, and the movement of electrons that will be around a cyclic ring. It means from this we understand that movement of electrons around the cycle or ring. So that is what in this whole chapters we will start we will try to understand that how the movement of electrons will occurring around the cycle or the ring. Okay, so the whole concept is lies behind this topic, that is movement of electrons around the cycle or ring. So if I talk that little bit about of the introductions part of pericyclic reactions, then what we say that in this pericyclic reactions we will study something different that what we are studying in reagents and intermediates and reactions mechanisms. Okay, so we are going to study the things which are not we have studied before. It means that it is a very new concepts. It means that in organic reactions, in organic chemistry, what we see that everything's are interrelated. It means that if you don't know the reagents, then you may trouble while doing that questions in intermediate, because the reagents will be there. And if you are solving that reagent questions, then if you don't know the intermediate, then that will make you problems while solving this reagent part. It means that organic is actually a interlinked. Every concept we should know, then only we solve the questions from organic reactions, organic chemistries. And the good part of the pericyclic reactions is that this is for pericyclic reactions. I am talking about specifically for pericyclic reactions. What we see here, that here we will no need to understand all these things. It means that this is not interlinked with any other concept like reagents and intermediates and reactions mechanisms. It means if questions will ask specifically only from the pericyclic reactions, then we don't need to understand anything about the reagents. If you don't know, if you have the zero knowledge of reagent, zero knowledge of intermediate, zero knowledge of reactions mechanism, then also we will solve the questions if that question is asked specifically. I'm talking about a specifically pericyclic reactions. Okay, but what happened now is CSR, net and GATE, that they are actually combining the questions. Means they will do reagents, intermediates, pericyclic reactions. They add all the concept and they will make one questions. Okay, so on that case we need to understand about the reagent and intermediate and reaction mechanism, all these things all. But if the questions will ask specifically from pericyclic reactions, then we don't need to understand anything about the reagents, intermediate and uh, other reactions mechanisms what we have studied in the organic reactions. It means that in pericyclic reactions we no need to understand any other concepts. It means it is not interlinked with other things like reagents and intermediates. So let it I says that for pericyclic reactions, what we say that we no need to understand. One thing is that we not needed the concepts of reagents. It means that I can write here no need, or you can say that no reagents used. Okay, for pericyclic reactions we not used any reagents, means the reagent is not needed. Okay, and secondly that intermediate, no intermediate forms here. It means that there is no need to know about of the intermediates. Okay, intermediate, no intermediate is formed here, no intermediates formed. Means we don't need to understand anything about an intermediate. If we have zero knowledge of intermediate, then also we can able to solve the questions from pericyclic reactions. Okay, and third is that if you here no reactions mechanism is used, so no concept of reactions mechanism applied. Okay, it means that if you don't have any concept of reaction mechanism, then also we can solve the questions that is for pericyclic reactions. Okay, another is that here the product form that is that have the specific stereo. It means that here one product will form. So you no need to understand about of the stereochemistry. So no concept of intermediate stereochemistry is used. Okay, so stereospecific product is for. It means only one product is for. So you don't need to look that whether it is R, whether it is L. So no need to look about of the stereochemistry. Means you don't need to vary about of the stereochemistry here, because here only one product is for. Okay, so there for pericyclic reactions this is the advantages for you, that we no need to look about of the reagents, we no need to look about of intermediates, we no need to look about of the reactions mechanisms, we no need to look about of the stereo also. Okay, so that is the good part for pericyclic reactions. And then the questions will come that if intermediate is not forming, if you are not giving reagents and it is not followed any reactions mechanisms, and it is stereospecific product is forming, then how that reactions is proceeds. The questions will arise to us that how the reactions that may proceed if all these concepts are not applied. Because for organic reactions, these are the basic things that has to be there for a reactions. But if it is not happening all these things, then how it is proceeds? So this reactions mechanisms, so this pericyclic reactions, how it will proceed? So pericyclic reactions proceeds. How it will proceed? It proceeds through intermediates. Okay, it proceeds through sorry, it proceeds to transition state, because here I said that no intermediate is formed. So this pericyclic reactions proceed through transition state. Okay, so this pericyclic reactions that is proceed through a transition state. Okay, and what I said in the before, that this pericyclic reactions, that movement of electrons around the cycles of the ring, that I said. So what we say, that what we understand here, that the pericyclic reactions proceed to a transition state. It means from here we understand here what we conclude, that pericyclic reaction that proceed through a transition state, and that transition state will be a cycle or ring. Okay, because that electrons move around the cycle, means during the reactions that electrons are moving around the cycles. Okay, and here no intermediate, no reagents, and no any reactions mechanisms concept is not applying. So what we see, that it will proceed through a transition state, and that transition state is a cycle. Okay, and that transition state, it is cycle or ring. It means that what I said, that in that reactions, whatever you do, that pericyclic reactions, in all pericyclic reactions, what you see, that the cyclic or ring transition state must be formed. It means that in all pericyclic reactions, if you look, that there must be a cyclic or ring transition state is formed. So before going to product, it will form a cyclic or ring transition states. Okay, so and here we are not giving that reagent. So what we are giving here, that here it needed heat. It means that if you just heat it, okay, that is not says that high heat. Simply if you give little heat, that we can mention by this, or photochemical conditions. So if it needed heat or photochemical conditions, that is represented by H nu, okay, to proceeds the reactions. Okay, so what is it, that here that intermediate is not forming. So what is forming here? Here forming a cyclic or ring transition state. And what we are giving to proceed the reactions? We give the heat or photochemical conditions to proceed the reactions. So these are needed to do a pericyclic reactions. So let's say if I take that examples, let's we have this type of example. Let's say this. Okay, now if you have like this, and let's say we have this one. Now if you give little heat to it, then what will happen? That what happened, that so here, that what we say, that intermediates and that reagents we are not giving. So how we will understand that this reactions is pericyclic or not? For that we has to look carefully about of that substrates. These are the substrates or reactants. So in pericyclic reactions, understanding that substrate is very very important, because from that substrate we will look that whether that reactions which happen or not. So substrate, identifying substrate is very very important in pericyclic reactions. It means if this type of substrate is there and heat is given, then we must do a pericyclic reactions. There may be happening a pericyclic reaction, so we will check through like that. Okay, so what will happen that if this type of substrates are there, then what will happen if you give little bit heat, then what will happen, this will go to here and this is going to here and this is going to here. So what I say is that in that pericyclic reactions, no intermediate is formed. Okay, so either we can write this or also this is also correct. It means if it is like this and if like this, and now if we are giving heat, so like this also, or we can go by this way also, because intermediate is not forming here, so we don't need to check that this intermediate is stable and that intermediate is stable, so that things we don't need to do, because here intermediate is not forming. So it will proceed like this or it may proceed like this. It may proceed like this or it may is proceeding like this or it may proceeding like this. Means electrons are moving like this or electrons may be moving like this. So because intermediate is not forming. Okay, so here what you write that. So for understanding, sometimes we used to mention that if they are proceeding like this, then what we say that this may be a positive because electrons are going from here. Not that this intermediate is not forming. I'm just writing for that understanding, because this bond, it means that positive and negative, that makes a bond. Okay, so if it is simply write like this, then it means that positive and negative. So that's why I'm writing here this is positive, let's say, because electrons are going from here, so I write here positive because electrons are removing from here and electrons are coming here, so I will write here negative. Okay, so similarly here that electrons are going to here, then this is negative and this is positive. Okay, and similarly electrons are moving from here, so it is positive and this is negative. So now how the transition state will form? So what I say is that here transition state form, that is a cyclic transition state. So how will you make here this and this? Okay, and this is breaking and this is forming and this is breaking. With that, this is there. Okay, and this is breaking and this is forming and this is also forming. This and this. So what we say, what we see here, that this is breaking and this is forming and this is breaking and this is forming and this is breaking and this is forming. So note that in pericyclic reaction, this is a concentrate mechanism. It means that at simultaneously both bond breaking and bond formations is occur. Okay, so pericyclic reactions is a concentrate mechanism, means both breaking and making of bond is happen simultaneously. Okay, so now what we see that if this is the transition states here, it means that it forms a cyclic transition state. Okay, so this is the cyclic transition state. So always in a pericyclic reactions, we look that there somehow forming a cyclic transition states. Now what you see here, after this, just I am erasing now. So what will form here, that what form here, see this is the bond formation is happening here, so make that simply. Okay, so this and this, here breaking is happening, here forming is happening, so I will make here forming, here this is breaking and here forming is happening, so this is forming and this was already there and this is breaking and this is forming, so this is happening here. Okay, so this is the final products. So what we see here, that it will go through a cyclic transition state and that final product is formed. So from here what we see, that what is why this reactions is happening even if you are giving a simply heat. So we giving simply heat and this reaction is positive. So what is the reasons behind this? So let me do again. So if it is like this, and here we have, and here we have like this, then what it is forming, that so it is moving to here and this is moving to here and this is moving to here. So now I'm not making that transition state, I simply writing the products. So this and this is comes here and this goes to here. Okay, and this was already there, and or I can write for understanding whatever that there that I am writing in the right, and what is forming newly. So let me do this one in a different colors. Okay, so this was there, this is there. Okay, so now what I say, that this is going to here and this is going to here, after that this is moving like this. Okay, so then the bond is forming here. So whatever there that I'm writing here, white one, this was like this and this is that way, and this hello one comes to here. So this hello one I write here. Okay, and now this hello one goes to like this. So I'm doing hello one this, and this white one was there already. So I write here that white one, and this hello one moves to like this. So I will move to like this. So this is what it formed. So from here what we see, that what here if we give little heat, then this is happen. Okay, so now what we see here, that this is a pi bond. How many pi bonds are there here? Two pi bonds. How many pi bonds here? One pi bonds. Okay, and how many pi bonds here? One pi bond is there. Okay, it's fine. Now what here, that two pi bonds, after that so this pi bonds, what it do, that it becomes a sigma bonds here. Previously it was a pi bonds, now it becomes a sigma bonds. It means that how many sigma bonds forms here? Two sigma bonds. Okay, so from here, that this pi bonds form this sigma bonds and this pi bond again form this sigma bonds. It means that two sigma bonds form. So from here what we see, that this is that thing. So previously we have the two pi bonds and one pi bonds. Okay, so two pi bonds and one pi bonds were there. Now after product it forms what it makes, that one pi bond with the two sigma bonds. Because this right one I'm leaving, we are not intact with this white one, this sigma bonds. We are talking about of this pi bonds. Okay, so this three pi bonds, what it makes. So this is 1 2 pi, this is 1 pi. So three pi bond, what it makes? 1 pi and two sigma bonds. It means that from two pi bonds, or I can say from three pi bond, what we make? We pour two sigma bond and one pi bond. It means that, let's say if you cancel this one, this and this here, then these two pi bonds make the two sigma bonds. And what we see, that electrons always try to stay in lower energy. Electrons always try to stay in the lower energy. Okay, now when that electrons is in the pi bonds. Okay, so in pi bonds, or I say that pi bond is less stable than sigma bonds. It means what we say that pi bond. So where it is less stable, where if it is in the high energy, then that is less stable, because electron always try to stay in a lower energy. Means if they want to stay in lower energy, means that bond is strong. So what I say that pi bonds, electrons are in high energy, and sigma bond, electron are in low energy. So this is the regions that electrons wants to move from the high energy to a low energy. So electrons wants to move from high energy to low energy to get stabilized. So that is the reasons that if you give simply heat, then also they actually do these reactions, because the electrons in the pi bonds, they want to stay in the sigma bonds, they want to go to the low energy. Okay, so if you give simply heat, then that will do these reactions. Okay, so that's why in this pericyclic reactions, even if you give simply heat, then that reactions will proceed. But the thing is that substrate should be like, substrate should satisfy the conditions. Like the substrates should be like that, so that reaction will proceed. If substrates are not like that, then how many heat if we give, then that will not do, because the main reasons why this reactions is happening is that the electrons are in the high energy and they want to go to the low energy. They are very interested to go to the low energy. So for that, if you give little heat, they will do the reactions. They proceed that reactions. So that is the reasons, that is the main concept that is used in the pericyclic reactions. Okay. So the main thing in pericyclic reaction is that we should understand the substrates. So that we will discuss in whole of the classes, that how the substrates are there, what are the substrates should be there. So we should remember, we should memorize, or we should know the about of the substrates. If this substrate is there, then only that pericyclic reaction is happening. Because we see that here that electrons are in high energy and they want to go to the low energy. For that case, they need they need a little heat. Also, they will proceed that reactions. We don't need to give the reagents. We don't need to do any other things. Okay. So this is that concept of this pericyclic reactions. And note that this pericyclic reactions, what you see that if we give heat, if heat is given, so like pericyclic reactions, if heat is given, some other reactions also happen. Okay, so what are the main possibility that if heat is given, the preference will be okay, so if heat is given, the preference will be that past preference, that if any reactions in the whole organic reactions, if heat is given, then past preference will be, we look that pericyclic reactions. Okay, pericyclic reactions will be the past preference if heat is given. Okay, now if that substrate is not satisfying that pericyclic reactions, but heat is given, then other reactions also chances to occur. So that reactions are like elimination reactions. So next preference, from if pericyclic reaction is not happening, then go for that elimination reactions, maybe sometimes possible. Okay, so elimination reactions. So we will go to the elimination reactions, whether any chance of happening elimination reactions. Okay. Now, if elimination reactions also not happening, then what we will look that, we will go for that whether decarboxylation reactions. So that is also occur by if we give simply heat. So why that is occur? That I say that electrons wants to move from high energy to low energy. Okay. So if other is that decarboxylations lesson reactions also may be possible. Now that either of all the three, these are also not happening, this is also we will not see that conditions, then what we look at next, we will look at cyclizations. So these cyclizations also occur by giving heat. So the organic reactions, what is important is that we should know the substrates, we should know that the conditions, that how that what are the conditions for elimination reactions. Okay, so we look at all the chances of forming elimination reactions. If elimination reactions is not happening, then we will go for the decarboxylation reactions. So we look all the possibility of forming the decarboxylation reactions. If not happening, then we go to the cyclization reactions. Okay, so in organic we should know that these things in a very clear manner. This should be, I explain all these things in the while discussing about of these chapters. So in organic, what is should know, we know every concept. Otherwise, you will not able to solve the questions. Okay, that's why organic is sometimes become little tough, because if you miss one concept, then that will affect you a questions. So you know that whole concept of organic. Okay, so if heat is given, then any of these reactions may happen. So we will look that in the pericyclic reactions, what things we will study for pericyclic reactions. Pericyclic reactions, what we will look that, so various types of pericyclic reactions are there. Okay, so first type of pericyclic reactions we will go, that is electrocyclic reactions. Electrocyclic reactions, first we will discuss it. Okay, and this is very easy concept. Then we will go for that cycloaddition reactions. Cycloaddition reactions. So here actually what we see that what type of substrates are there, and how that will occur. That is the, what is the molecular orbital that is involving, that we will discuss. Okay, for electrocyclic reactions and cycloaddition reactions. And third is we will go for that in reactions are there, very important in reactions. Then we will go for that sigmatropic reactions. Sigmatropic reactions. So these things we will study in this class. So we will discuss one by one: electrocyclic reactions, cycloaddition reactions, in reactions, and sigmatropic reactions. But before we start these types of pericyclic reactions, it is very important to understand the general concept of a molecular orbital theory. Although that is discussed in the organic chemistries and organic chemistry also, so it is better to give little introduction about that organic that molecular orbital theory. Okay, because this concept is really huge while studying these variety types of electrocyclic and cycloaddition reactions. Okay, so this representations representations of molecular orbital theory. So this is the general concept that is used for whole types of reactions. Okay, used in all types of pericyclic reactions. So this is the general concept. I'm not talking any particular pericyclic reaction, electrocyclic, cycloaddition. So this concept is used in whole pericyclic reactions. Okay. So this is the general concept of things that is used, that we will discuss, that we will used tremendously while discussing about different types of pericyclic reactions. Okay. So this molecular orbital theory, this representation we should know. Okay, so what we know that we always know that if these are the lobes, like we have the p orbital lobes. Why you are talking about a p orbital lobes? Here we will talk about of the p orbital. We will not talk about of d orbital lobes. Reason is here we are using that organic means carbon chemistry. Organic means carbon chemistry, or this carbon or hydrogen chemistry. So in carbon chemistry, what we have that 2s2 2p2. This is the molecular orbital. It means that here d orbital is not there, or f orbital is not there. Here what we have that 2s and 2p2 orbital, means p orbital is there. So this 2s orbital is filled and p orbital is vacant. So because 2p6, so 2p2 is there, so p orbital is vacant. So this p orbitals involves in the molecular orbital theory. So here we will talk about of that p orbital. We will not talk about of the d orbitals, because this is carbon chemistry, and in carbon we don't have the d orbitals. Okay, carbon we don't have d or f orbitals. So we will not talk about of it. So we will talk only about of the p orbitals. So what we have that in the p orbitals, we see that p orbital is like this, and what we see that one is positive lobes, another is negative lobes. So two lobes are there, one is positive and another is negative. Okay, this although this is the like this, so both are same. So one is positive and another is negative. That is the general p orbital lobes. Okay. And d orbitals, how it looks, then that will be going to be, that we will not discuss because here d orbitals is not used. So d orbital is like this, like that, or like this. So this is the d orbitals. Okay, but here we will not discuss about d orbital because d orbital is not present in the carbon. So we will talk about of p orbital lobes. So p orbital lobes, how many lobes are there? Two lobes are there. Like d orbitals, how many lobes are there? Four orbital lobes are there, but p orbitals two lobes are there. Okay, and what things we see that in the p orbitals, if this is there, okay, and another lobes are there is present. Let's say this is one p orbital, another p orbital. Let's say, okay. So now, if it is, let's say if it is positive and if it is negative, then what happened that this positive and positive, and this is negative and negative, if both have that positive in the same sides, like above this is also positive, this is also positive, then what will happen that bond formations occur. Bond formations happen. But what we see that if the same things, like if I draw here and if I draw here, now if it is positive and it's negative, but this is, let's say, negative and this is the positive, on that times these interactions will not happen, because positive and negative the interaction will not happen. On this case, no bond formations will occur. So no bond formations. So what things are needed for that bond formations? They have that in the both above the same signs should be there. Then the bond formation will happen. Otherwise, if there are different signs, then there will be no chance of making bond. Okay. So this the general that all the that is discussed in that molecular orbital theory concepts. So these are the general things that if this have the same sign, then bond forms. If they have the different sign, then there will be no chance of bond formations will occur. Now what we see here, uh, let's say that let's we discuss about of the one carbons. Okay. Let's say that 1,3-butadiene. 1,3-butadiene. It means that carbon butadiene means 4. So 4. Okay, and 1,3. It means 1 and 1, 2, 3. So 1,3 have the double bonds. Okay, this is the butadienes. So let's say that this is butadiene. So what you say that now you want to make that molecular orbitals for this butadienes. So first our work is to count that number of carbon atoms. How many carbon atoms are there? 1, 2, 3, and 4. So 4 number of carbon atoms. So first is that for orbital theory, for orbital or like that for MO representations. So this is that actually just for understanding. After we understand that, we just use that tricks and we solve. So we will not need to represent always this molecular orbital theory. You just will do once, and next we will apply the tricks and we will solve the questions. Okay. So for beginning, for understanding, I am representing the MO and I am discussing about the whole concepts. Okay, so after solve it, I will give the tricks and we will solve that questions very quickly. So for MO representations, what we look that first count the number of carbon atoms. Okay, so number of carbon atoms equal to what we will do that number of, this is the first point, number of carbon atoms equal to number of lobes, that is p orbital lobes presence. Okay, so number of carbon atoms equal to number of p orbital lobes presence, or also we say that the same number of uh, orbital energy presence. So this is the past concept about of while we are doing that MO representations. First we look at number of carbon atoms. From that we see that that number of the same how many number of carbon atoms are there. The same number of p orbital lobes we will make, and that same number of orbital energy also we will make. Okay. And next what we see that, so from here what we have that, let's say here we have that how many carbon atoms? 4 carbon atoms. Okay. So here 4 carbon atoms are there. So 4 carbon atoms. So what we'll do that? We will make like this an energy. Okay. So this is that energy to the increasing order. So 4 number of carbon atoms. It means that 4 number of p orbital lobes is 4 and number of orbital energy also 4. It means that energy how will make by the function of psi 1, 2, 3, and 4. So we will make by this is psi 1, this is psi 1, this is psi 2, and this is psi 3, and this is psi 4. Okay, and now that lobes, number of p orbital lobes, that is also 4. So 4 number of orbital lobes also will make. So let's make this 1 p orbital lobes. So 4 I will make, 2, 3, 4 I can make that lines here. Okay, so now we will make that 1, 2, 3, and 4. Okay, similarly here we will make that 1, 2, 3, and 4. 1, 4. 1, 2, 3, and 4. So because here we have that 4 carbon atoms, so 4 p orbital lobes. Okay, 1 p orbital lobe, 2 p orbital, 3 p orbital, and 4 p orbital lobes. Okay, so by looking the carbon atoms, we draw up to this. Now this is the first point, and the second point is that what we say that the terminal lobes. Here what we have that said psi n. This is psi 4, psi 3. So n. Okay. This psi n, if n equal to odd number, then terminal lobes have same sign. Okay. And if n is equal to even, even number, then terminal lobes have same sign. Terminal lobes have different signs. Okay. If n is even, on that case, terminal lobes have different signs. If n is odd, then terminal lobes have same sign. Okay. So from here, what we say that sign means that I say that here, like I can draw here. This is, so this is what n is 1 here. It means that this is odd. This is even. This is this 2. Okay. This 1. This 3. This is odd. And this 4. This is even. So if it is odd, then terminal lobes. So these are the terminal lobes. Okay, these are not terminal lobes. These are the terminal lobes, which are the in. So these are the terminal lobes. Okay. So these terminal lobes have the same sign if n is odd. It means what I say that here if it is positive, then it is negative. Then this also has to be the positive. Okay. So if it is positive and negative, then this also will be the positive and this also the negative. Because the terminal lobes, if n is odd, they will be the same. Similarly, this is also odd. So if it is positive and if it is negative, then this also will be the positive and this is also will be the negative. Because the terminal lobes for odd case will be the same, and for the even case that will be the opposite, have the different sign. So if it is positive, let's say, and if it is negative, then this should be a negative and this should be a positive. Because if it is even, then there will have the different lobes or different signs. Okay. So similarly, this is even. So if it is positive and if it is negative, then this is negative and this is the positive. So that's what the second point says. Okay, this is the first point, this is the second point, and third points I will write here. Third point, what it says that psi n, if n is equal to odd, then what is that? That it have plane of symmetry. So if n is odd, then it have plane of symmetry. That POS is present. And what is that? C2 axis will be upset. That what says that if n is odd. Okay. Now if n is even, then what? That it not have plane of symmetry, that is POS is upset. And what? C2 axis is present. Okay, so that what it says that if n is, so this the 3 points you have to remember. First is that, and second point is that, and third point is this. Okay, so if this point if you use, then you will able to draw that MO diagrams for of any carbon atoms. Okay, so now what we say that if n is odd, then it have the plane of symmetry. So plane of symmetry means from middle if you have to look. So let's say it's here. Okay, so what is that? That terminal lobes, plane of symmetry. Okay, so before that another point also, that fourth point. So another point is that that is about of the knots. So what do you mean by nodes? Nodes is that the finding of electron density is, or I can write, nodes is that the position or place where finding or where getting of electron density is zero. That is called the nodes. Okay, and here there is very important that these nodes, okay, psi n, for psi n, nodes is equal to what? That is n minus 1. Okay, so this is the very important points. For psi n, nodes is n minus 1. So from here we see that this is psi 1. So nodes will be, I'm just erasing this one. So if I write here the nodes, okay, so if psi 1, so psi nodes is equal to, that is n minus 1. So here psi 1, so nodes will be 0. And for this, nodes is n minus 1, 2, 2 minus 1, that is 1. Here that is 2, and here that is 3. It means that for psi 4 you will get the 3 nodes, here you will get that 2 nodes, here you will get that 1 nodes, here you will get that 0 nodes. So applying these 4 concepts, we will make that orbital representations for any organic molecules. Okay, so now what we see that, so here we have to make that nodes. Okay, also one thing, how these nodes we say, let's say if we have, this is one p orbitals, okay, this is plus and this is negative. Another is, let's say, this orbitals, another is, let's say, these orbitals and these orbitals. Okay, so if it is positive and negatives, and now if it is also positive, then this is also negative, then here that bond formations will occur, and here that electron density is present. So if you are like this, then here electron density is present. So here electron density is present. Reason is that here bond formations occur, because bond formations is happen. Now in this case, let's say another things, if it is positive and if it is negative, and it is negative, it is positive, it means that here no bond formations is occur. Okay, here no bond formations is happen. It means that if there is no bond formation, so bond means that, and this is formed by positive and negative, so here electron is present. Okay, so here bond means electron presence, but if there is no bond, means that no electron is present. So no electron density is present. It means that here we have the nodes, because nodes is where the binding of electron density is 0. So here we have the nodes, but here no nodes is present. Okay, so that's what we look here. So what is said that here that nodes is 1, here nodes is 2, here nodes is 3. Okay, so applying this rule for concepts, we will make that MO representations of any organic molecules. Now what we look here, so if odd, then what you say that odd, then POS is present, and if even, then POS is absent. Okay, this is the one thing we have to remember, and POS is absent and CO2 is absent here, and here C2 is present. That is not needed, but important is that POS. Okay, so what we see here, so that we have done that odd means plane of symmetry is present. So plane of symmetry, when you say that, that will reflect If it is positive, then that same after 1 2, this is positive, here also 1 2, here has to be positive, here negative, this is negative, means that that should be reflect. It means that if we have like this positive and negative, and if we have that, so here if we are drawing here plane of symmetry, means that we know that if it is positive and the negative, then this also has to be positive, then only it will reflect to it. Okay, similarly if it is negative, then this also has to be negative, so that this and this get reflected. If positive, then this also has to be positive, so that this and this has to reflect. So that is what we say that plane of symmetry. So if it is positive, then it's also positive, so that that will reflect. Okay, also from terminal lobes they have the same signs. And secondly, what we say that here node is 0. It means that everywhere there should be a bond. It means that I have to make here also positive, here also negative, so that bond formation is proper. Similarly, here also positive, here also negative. So we will see that plane of symmetry is also present, and nodes is also 0, and terminal lobes also that is same. So this is that psi 1 functions. Similarly, if you move to the side 2, here what node is 1, so make sure that we will make one node. And even it means that the terminal lobes have the different sides. Okay, that we make it. Now what we say that we have to make one node, and if even then plane of symmetry is upset. Okay, so it means that here positive, then negative. So yes, that plane of symmetry is from here also there is no plane of symmetry, because this has to be reflect. Okay, now what we say that we have to make one node. So if I make here positive, if I make here negatives, and if I make negative here positive, then what I see that there is one node here, and here bond, here bond. So this is that cyto function. So just match all the four concepts, that is this number of carbon atoms, and this side that is terminal lobes, another is about of the nodes. Okay, and that is about of the POS and about of the nodes. So applying this for, okay, applying four concepts, we have to make this diagrams. Okay, so this is positive, so now this side 3, that is odd. Okay, this is odd, so plane of symmetry is present. So if it is positive, this is positive. So now what I have to know, I have to also know that I have to make that two nodes. Okay, so two nodes means if I make here negative, if I make positive, then that will be one node is there, but that plane of symmetry is there, that should reflect. It means that I again have to make here negative, here positive. Okay, so that this is one node, this is one node, two nodes. Okay, plane of symmetry also present. Similarly, if I make here, I have to make that three nodes. So this is even number, so plane of symmetry is absent. So this one. So if it is positive, negative, then I have to make here. I have to make here the three nodes. So here negative, here positives. Okay, and what I make here, here positive, here negatives. So here you see that plane of symmetry is also absent, and we have the three nodes, one node here, one node here, and one node here. Okay, so in this way we will make the MO representations of any organic molecules by using the four concepts. Okay. So in this class we will stop up to this. In next class we will discuss about of that electrocyclic reactions. So next class we will proceed that one type of pericyclic reactions. That first type is electrocyclic electrocyclic reactions. So today I am stopping here. In next class we will discuss about electrocyclic reactions. So thank you.